Good morning to all of you. I am Oveshwara. I am going to talk with you our chapter number 1, class 12 physics. According to me, the physics it is a very easy subject. So we are discussing about the very easy subject, and it is a easy subject and it's also easy topic is that, so you can understand easily with this topic. So we can say about the topic of continuous distribution, continuous distributions of charge. So now first of all, what is the continuous? It means what we are discussing about that if there is an infinite similar large thing is that. So if we are talking about the infinite similar large is that, it means it have a infinite, so it is the largest value. So largest value have some of the charges are there over the whole of the length. Okay, so suppose we are discussing about that the you have wire is that it is a still longest wire of that. So we have to discuss with the smallest area of the wire. It will be produced our what it will be produced give it will be gives us that the smallest value have a smallest charge over there. So we are discussing about the continuous charge. So there is a three type of continuous charges. First one, it is what, see, there is a three type of charges. First one, it is our linear charge distribution. Second it is a surface charge distributions, and third one it is my volume charge distributions over there. Okay, so surface charge, volume charge, and my uh, surface charge, linear charge, surface charge, and volume charge distributions. So now see linear charge distributions. What will happen? Linear charge distributions. So we are talking about the linear charge distributions. So now consider the continuous charge distributions over the line as shown in figure. So see here what will happen. There is a one line is that it have a length, it is dl, it have a total length, it is l, and total charge it is equals to q. Total charge it is equals to q. But what will happen now? The total charge it is q. Then we are talking about it charge it is q. Here what will happen, there is a dl is that. Okay, so dl charge it is dl it is area, smallest area, and the charge it is equals to our very small area. It is that means it have a charge, it is our we have less. So we have less charge, it means what, it is minimum charge, it is delta q, or we can say it is a dq. So now let amount of the charge per unit length of line be the lambda is called that the linear charge density. So see now what is the linear charge density? The amount of charge per unit length, amount of charge per unit length of line B lambda, it is called the linear charge density. Again, what is that? Amount of charge per unit length, amount of charge per unit length. It means we are just considering as a small length of that. So it is our amount of charge per unit length is that, and it is denoted by lambda. So it is called the linear charge density. Now linear charge density it is equals to what? The formula it is that total charge on line divided by length of line. So see here we are written as our total charge upon total charge on line divided by length of line. So here, so see q by l it is equals to my charge, it is total charge, it is how much q, and our length of total length it is my l. So total length it is my l, and our total charge it is what, our total charge it is q. So we can say lambda it is equals to q by l, and now unit of lambda it is equals to see coulomb inverse. Why coulomb inverse? Because see the value of our charge of coulomb it is equals to what, the q it is measured in coulomb. See, and also what will happen, our l it is measured in meter inverse. Okay, meter. So meter inverse, why we are written? Because it is in downside. So what will happen, there is a, we are just talking about the it is only meter. So what will happen, there is a q by l it is equals to unit of lambda is coulomb inverse. So unit of lambda it is equals to coulomb inverse. Now we are talking about if the distributions is not uniform, then lambda will be different point on the line. So in case of linear charge density is represented as lambda r. Why we are talking about the lambda? With any position vector we are talking about any particular positions, how much value of lambda over there, how much density, line charge density over there, we are discussing about it. So it is our It is our line charge density. So now line charge density, it is equals to what? Lambda r. It is where it is at any particular point. We are talking when it is not uniform, is that. So at point line having the position vector, it is r. And now what will happen is, imagine that the line is divided into large number of small segment of length. Okay, so one of the what will happen, one of the your ball is that it is divided into small marbles. Okay, total ball, it is divided into small marble, or you can what you can say, puffed rice you are eaten that the in your in on Makar Sankranti days. Suppose you are just considering as a puff rice of one of the particle, it is a puff rice, one of the particle, it is the one of the smallest area. So it is, we are considering about, we are just considering this one, it is a my what this one, it is our this one, it is our smallest area we are just considering. So we can take it is our dl, line element dl, and having positions vector, it is also r. So see here, element, line element, it is dl, and positions vector, it is our r. So with respect to O in shown figure, so now what will happen, we require the value of q. So value of q, it is equals to, so c. Now we are talking about the, if we require the value of q, if we require, sorry, again we are start, what will we require, just we require the value of q. So q, it is equals to what, q it is, see here we are written as lambda, it is equals to q upon l. Okay, q upon l. But what will happen, there is a q upon l is that, so we are talking about q upon l, it means, but we require what, we require the value of q. So q, it is equals to what, we can return q, it is equals to lambda into l, lambda into l we can write. So see, but whenever we are talking about that, there is our there, whenever we are talking about the small elements, on the time we can written as dq, it is equals to lambda into dl. Okay, into lambda into dl. But what will happen, it is we have to talk about any particular position, so we can written as r dash, r dash. Okay, so we can written as our r dash. So lambda r dash is that, it is where our density at where, at any particular positions. Now afterwards we are discussing about the another, it is a more given, so we are not required. So we are talking about the another topic is that surface charge distributions. Okay, so surface charge distributions we are talking. Now again we are talking about that another topic is that our surface charge distributions. So now surface charge distribution is what? First of all, surface means area. Okay, so surface means area. So see here, now what will happen, there is another one, it is that, so see what will happen, there is a, see this one, it is a, we are talking about any particular area. So see this one, it is my suppose surface. See this, what will happen, there is a, we are discussing about the surface. So see, suppose here it is a one surface. Okay, here it is a one surface. So one surface have a area is that it has a particular area, surface have a particular area. So area have a, what will happen, it is contain the sum of the charge, it is contain the sum of the charge q. So sum of the charge q is that. Okay, so we are talking about the charge q, surface charge distributions. So we are required to first of all understand about that the surface. So surface, it is any particular area, and any particular area have a surface have a any we are talking about any particular surface. The surface have a any particular area is that. So particular area contain the charge. Okay, so we are talking about this kind of situation. So see here, charge is distributions continuously over the surface, so having surface charge density. So surface charge density, it is denoted by sigma rho, sigma r dash, sigma r dash, it is denoted by sigma r dash. Now sigma r dash, it is equals to what, sigma r dash, it is equals to, see here what will have sigma r dash, it is equals to total charge density upon total charge on surface divided by surface area, total charge on surface divided by surface area. So see how much charge. So see here, we are discussing about this uniform charge. Okay, uniform surface is that. So uniform surface have a total charge, it is, we know that is, it have a charge, it is how much charge, charge, it is equals to q. But whenever we are talking about the uniform charge, uniform area means uniform area have a uniform area have a uniform sorry, uniform surface have a uniform area. So uniform area is that. So we can talk about that the sigma, it is equals to q upon a. Sigma, it is equals to what, sigma, it is equals to, see this sigma, it is equals to, we can written q by a. Now what is the unit of this sigma, unit of the sigma, it is equals to what, sigma, it is equals to, here see what will happen, there is here we are talking about the sigma. So sigma, it is equals to what, see it is in unit. So see sigma, it is unit, it is what, here see unit, it is my sigma, it is equals to coulomb, coulomb meter raised to minus 2. Why coulomb meter raised to minus 2? Because see the coulomb q, it is measured in coulomb, and area a, it is measured in meter square, a is measured in meter square. So area, it is measured in meter square. So what we can say, if the area, it is measured in meter square, then we can say this is our unit of the our sigma, it is equals to what, unit of sigma, it is equals to coulomb meter raised to minus 2. But now what is the main another thing is that we are talking about the another thing, one is that see, suppose see here what will happen, there is a non-uniform area is that. Okay, so this one, it is a non-uniform area, but now we are required to measure the value of q where at any particular point. So suppose see, this is my origin and it is from here to here, this is from here to here, it is at particular point. See this is my y-axis. Okay, this is our x-axis. So we require any particular area, so it have position vector, it is my r dash, position vector, it is my r dash. So position vector r dash is that. So what will happen, there is r dash is that, it means suppose see here what will, again I just shows you what will happen. Okay, so see this is our area. Okay, so see, wait a minute. Okay, so see, suppose it is my x-axis, suppose it is my, here see it is my x, here it is my y. Okay, from here this is our irregular, any of the shape is that, from here it is my charge cube. Okay, here it is my charge cube, so here to here it is our position vector, we can written as r dash. It is our position vector, we can write, it is my r dash is that. Okay, so see, now it have a charge, it is equals to how much charge, it is equals to suppose dq, and we are just considering this much area, small area, so it is equals to my what, this area it is equals to, we can written as da, we can considering as a da. So but before that what we are written, before that we are written q, it is equals to what, q it is equals to, we are written lemon sigma, it is equals to, we are written q by a. Okay, we are written q by a. So what will happen if the q by a it is, if we are written, then what will happen, sigma it is equals to q by a, then so sigma it is equals to q by a here. So what will be there here, for whenever we are talking about the small value. Okay, so sigma it is equals to, whenever we are talking about the small value, and small value it is what, it is my dq by da. Okay, dq by da, but we require the value of dq, we require the value of dq. So what will happen, value of, we require the value of dq. Okay, so dq it is equals to, see now sigma it is equals to dq by da, but we require value of this dq. So dq it is equals to what, we can say this one it is gone in this side, so this one is gone in this side. So what will happen, the sigma into da, it is equals to dq. But whenever we are talking about the sigma into dq by da, okay, what will happen, there is a, it have a position vector, sigma have a position vector, it is a r dash. Okay, sigma r dash, so dq is equals to sigma r dash by da. So due to this charge, dq will be what, so see now there is a, we are talking about the dq it is equals to sigma r dash into da dash. Okay, so see this one it is our final value of whenever we are talking about any particular non-uniform value. So non-uniform value, it is, we know the density of that and area of that, then we can count the how much charge over there, or maybe we can know there is a only density and charges, that we can calculate the how much area over there. So see, this is our what, this is our surface charge distribution, this is our surface charge distributions. Now afterwards we are talking about the another one, another topic is that it is our volume charge distribution. Now, so see again, our another topic is that volume charge distributions. So volume charge distributions over there. So first of all, what is the volume? So see, we are talking about the volume. So what will happen? There is first of all, see now here, what will be there? Suppose see this one, it is my block. Okay, this one, this. Okay, it is not proper. Don't require space. So we have to make it is big. Now see here what will happen? There is a we are just drawn this line. Okay. So now see this and this. Okay. So this is our volume. Okay, this is our volume. So whenever we are talking about the volume, it is total volume is that it is three dimensions are there. So whenever we are talking about the three dimensions, it means what? So see, there is a three dimensions volume. So we are required total charge over the volume. It is our Q and the volume it is our V. Okay, total charge it is Q and volume it is our V. So what will happen? There is a, we are talking about that the our topic is that see we are discussing about the volume chart distributions. So in figure, so see there is a suppose we are considering as a small volume, okay, small volume we are considering and small volume it have volume V and the charge it is equals to Q. So see now what will happen as shown in the figure. We are talking about that the volume charge density is charge per unit volume. It means what? Charge per unit volume. So Q by V it is our total volume charge density. So see now again what will happen? There is a rho it is equals to what? Rho it is equals to Q by V. So rho it is equals to total charge upon total volume. Total charge upon total volume. But see the unit of our rho, unit of our rho it is equals to what? Coulomb meter raised to minus 3. Now how the coulomb meter raised to minus 3. So see what will happen whenever we are talking about the coulomb raised to minus 3. But because of what will happen there is see the q it is measure it is in coulomb and we our area sorry our volume it is measured in our volume it is measured in what q it is equals to q measured in coulomb and our volume v it is measured in our meter raised to 3 but see this one it is q by v is that so meter raised to 3 going upside so what will happen this is power plus then we can return as minus 3 because it is going from down to upside so it will be become as coulomb raised to minus 3 so what will happen now see, this one it is our Q, it is equals to what total charge upon total volume Q by V is that unit of rho is that coulomb upon meter raised to minus 3. But now we are talking about that the coulomb raised to minus 3. So see, now we are discussing about that the whenever our non-uniform. See, first of all, we are discussing about the uniform volume. Now we are talking about that the non-uniform volume. So whenever we are talking about that the non-uniform volume, what will happen? There is a so now see what will happen whenever we are talking about the volume charge distribution and when it is a non-uniform volume. So non-uniform volume it means what? So see non-uniform volume means see here what will be there here it is suppose irregular volume over there okay irregular volume over there. So what will happen? Suppose we are talking about this one this suppose see Okay, so see this one, it is our volume, but it's shape, it is not proper. Okay, its shape, it is not proper, so it is a irregular shape. But see, irregular shape we are just considering as a small area element. Okay, small area element. So this small area element contain the our volume, it is dv. Okay, dv. So the contain volume, it is dv. And now suppose the charge, it have also small value dq is that. Okay, dv and dq is that, so we can return as our dv by dq. But see, sigma, it is equals to rho it, sorry, rho it is equals to what? Rho it is equals to, rho it is equals to, we have rho it is equals to q by v. Okay, q by v, but we require the value of q, then we can put it here. So what will happen, there is a q by v, it is equals to, oh, q it is equals to, q it is equals to, q it is equals to what? Q it is equals to rho into v, rho into v. Q it is equals to what? Rho into v. Now what is the here? It is our density, volume charge density. So but see, whenever we are talking about any particular distance or any particular position, so it will be what will happen? It will be my, as see, position vector, it have r dash, so rho r dash into our v is that, rho r dash into v is that, it will be gives the value of q. But whenever we are talking about the small value, so we can return as dq, it is equals to, see here, it is a dv, dq it is equals to rho r dash into dv is that. So what will happen, there is a dq it is equals to what? Dq it is equals to rho dq it is equals to rho r dash into dv dash. Okay, rho r dash into dv dash. So this is our volume charge distribution over there. So see, now here I am going to over this lecture, but I you have to do these three definitions. You have to write down homework in the form of definitions, and also as well as you have to write down, I already given to you this work, but again I am given. What will happen? See, and you have to write down these examples. Okay. So see, now you have to write down these examples. First one, it is a what is line chart distributions. Second one, it is a what is volume chart distributions, and third one, the what is surface chart distributions. So you have to write down, and also you can see here I already written, there is a our line chart distributions, it is what? Delta lambda, it is equals to delta q by delta l. Then after its unit is, we are coulomb meter inverse. Then after we are talking about the surface chart distributions. The surface chart distributions, it is what? Sigma, it is equals to delta q by delta s, and its unit is what? Coulomb meter raised to minus 2. And then after we are talking about that the volume charge distribution, so volume charge here, and its a unit, it is what? See, delta q by delta v, and its unit, it is equals to coulomb meter raised to minus 3. So coulomb meter raised to minus 3, it is a unit of the our volume charge distribution. So again we are talking about that the, so see, now what will happen? We are talking about the volume chart distributions. So you have to write down this homework, three questions: line chart distribution, what is line chart distributions, what is volume chart distributions, and also as well as you have to write down the what is the what we can say, what is the surface chart distributions of the three of this question. You have to write down in your notebook and send on the Google Classroom. So I hope guys you are understand, this is my lecture, and it is very easy, so you can easily understand, I hope. So guys, we are in next lecture, we are discussing about that the our another topic is that our Gauss law. Okay, so our Gauss law is that, so we are discussing in next lecture Gauss law. So still you are keep learning and keep watching the video and keep main, mm, be safe. Okay, so thank you guys. If any doubt, if any, then comment, then you have to comment in comment box, and as well as you have any of the problems in the questions, you can't understand anything, then you are I'm it is in my you can send me as a message in classroom, and as well as you can send me as well as on the Google Meet, you can talk with me. So thank you guys, thank you so much.